What you'll see in today's video is going to be a tutorial where I show you how to create this random pattern, which what it does is it creates a random set of subdivisions, and it's using a technique that I've shown before using a pattern where we rotate randomly starting with the square grid. And so you'll see all of the steps here. I'll be going over the simplified version and also the work session where I show a little bit more detail. So if you want to download this and learn a little bit more about parametric design, I'm going to be going over all of the steps and you can follow along and download the script to see how it was created. So thank you for being here. Hopefully you're excited, and let's jump right in. The first thing we're going to do is bring in a square grid. So I'll double click here and type in square. Now we have the square grid that we can input or change the location using construct point, and we can also route it through an empty point component. This way we can see where that is going to be located, and we can also change that location. For now, we can keep it at the origin. The size will go here to 5. The extents, we'll keep it the same for both X and Y for now. We can always change that at the end. All right, so we've got this grid with all of these cells. Now what I want to do is just pick one of them, and I'll show you what I want to do to all of them. That way I can show you an example first of what we're going to be doing to all of them. We'll take these cells, we'll go to list item to pick just one of these cells because they're all actually contained within this component. And so when we plug this into the list item, it actually picks the whole row, and that's because this is a grafted set. So when you see a dashed line, that means that it's grouped within this. There's a set grouped here, there's a set grouped here, and we can change those, or we can flatten the output. And now we're just picking one of them because it creates one long list and it picks the first one. So now we can use two different components. Discontinuity to pick the corner points, and average to average out those points to the center point. So now that we have those points, now we need to just pick two of these to connect it to. So the way to do this is, once again, use list item. So I like to slide it over, tap Alt to create a copy. Now we can pick just one of those points, or two if you add another one here. And now we can connect the center to this point and the center to this other point. So at this point, we've got one of them taken care of. So now what we can do is do it to all of them. So I'll take this list and either override it with all of them, or plug this in and then go to graft. So two ways of doing it. I think I like this way, a little bit cleaner. Why? Well, we still have the center point and these rotations. So what we can do is take that center point and rotate it, and use that center point as a rotation point, and rotate both of these geometries or these line segments. Now we can plug in a angle in degrees. So I'll go here to 90. Why? Because 90 is going to be how a square is made. So using 90, I'm just rotating it 90 degrees. And so how do we make it so it rotates stepping by 90? So we do 90 multiplied by 5. And it doesn't matter what number we use, there's always going to be a step of 90. And so if I move this around, this will rotate it evenly using just one number. So now what we need to do next is rotate it using 90, but plugging in a random set of these numbers. This way we can have however many cells. If we have 64 here, we want 64 different numbers that we can rotate randomly by changing this number. So let's do that. Bring in a random component. We know the range. It could be any number. Now, how many of them? Well, we know that when we look at the cells here, we look at the list length, and this will tell us, just by plugging this in here and flattening the input, how many items are plugged in, and that's how many we need to create. So we'll start by number, seed, we'll just go to 3, which is more random solutions. And the range is going to be construct domain, and using start and end, 0 is going to be by default, and then the end could be 10. Now here's the trick that I learned from one of my viewers, is if you look at the random output, you're going to have a lot of decimal points. If you right click on top and you go to output, rather than integer numbers, you change it to integer. So when you click this one on, now you'll have all of these numbers, 64 random numbers between 0 and 10, and they are all whole numbers. I will hide kind of the wire there. Now these random numbers can be plugged in here. What I like to do is unplug this, graft. The reason why is because these are grafted, and these also need to be grafted. And so if we look at this, actually no, it needs to be plugged into this one, the rotation into this one, and this number is going to be plugged into here, but this one is the one that's grafted. So we're using this second number for this one. So it's 90 times 3, then 90 times 7, and that is how we're able to rotate randomly. So here you'll see, this is the pattern that we create using this technique. Now I've shown this technique before using a different pattern. So just understand that this application is can be applied to different patterns. But for this application, I'm showing mostly like an architectural application on how you can use an algorithm like this. So using this, we can now hide everything except for these. And if we change the seed, we'll have random rotations. Now, what I wanted to do here is show you the simplified version, but I did a work session where I created an architectural design based off of it. And so the next thing would be to take this and extrude it up randomly. So since we've already set the stage here, we're going to copy this over. Now, how many of these do we have? 128. So let's see. Yep, so we have 128 here. Now we're going to take these random numbers and extrude these geometries in the Z direction. Here we need to graft the input. And so if we look at it here, 64, 128, we actually need to create these many. So I'll use this 128 Now what happens here is when you have domain start of 0, you have some that will not work. So this is why we can use one number for both and then they will be consistent, or just lower it to the minimum number being 3. I do see there's still something going on here. 128 numbers and 128 of these. Let's see if I can flatten this. Okay, so now everything's working here. Okay, so the cool thing about this is it creates this random set of organized kind of cubbies, and we can expand the size. So we can say, let's say each cubby is 10 feet, or let's say if it was going to be an art gallery, like what you'll be seeing later, you can say 20 feet per space here. We can also bring back the cells, so you can see kind of how they're organized. And now with these, let's see here, these line segments, let's see if we can offset this for the sidewalk. Positive 3.5 and then negative 3.5. Loft these two and then use region union. Bring together all of those regions and then use boundary surface. I'm going to clean that up a little bit. Now we can also do this. Take those endpoints use a circle. But here at the start and end points, I actually want to call or get rid of the duplicates. So start and end, flatten the input. We'll have 131 inputs, and using this and an addition, 3.5 plus 3.5. And use that as a radius. Now we can use region union to now bring together both this one and this one. Now we have a radius at the edge, making it easy to be able to circulate. We have it like this, as well as having the ability to, let's say, expand that circle if we want some additional areas here. Now, at some point they do intersect. I think that's when we have some issues. I think it's just a calculating issue. But regardless, let's say if we do a 1 foot overhang or a 0, this gives us a really neat idea on how to use the random component and how then to take, something we developed here within Grasshopper and turn it into an application of architectural design. And this could also be a form finding exercise, because when you're using random, you don't have the ability to know what it's going to look like. And so if we hide the input here and we just see that we can change the seed just to randomize the rotation, we also can change the seed for randomizing the height. And we can also set one for, let's say, offsetting the walkway for it to be random. So with this, you'll be able to use these techniques for other designs. So what I'm going to do now is clean this up, and I'll share this along with the other one that you'll see in a bit. So let me know if you have any questions. If you want to learn more about parametric design, check out my website. I have more resources there and the ability for you to contact me if you want one-on-one help. So thank you very much for being here, and let me show you the rest of the work session